Hello students. Welcome back. Before we start today's lesson, let us revisit our last discussion on physical quantities. Remember, we defined fundamental and derived quantities as types of physical quantities. We mentioned some of the examples of fundamental and derived quantities. We also discussed the differences between the fundamental and derived quantities. And, finally, we distinguished between fundamental and derived units. Now, without further delay, let us look at today's lesson objectives. Our lesson today is on measuring the fundamental quantities using appropriate tools. By the end of this lesson, you will be able to know the various tools used for measuring fundamental quantities, demonstrate how to use the appropriate tools for measurement, understand how to derive the dimensions of some physical quantities. Are you ready? Without further delay, let us dive into today's topic. Measurement is determining the size, length, quantity, or degree of something using a standard unit. It involves comparing an unknown quantity with a fixed standard, called a unit, to express the value of the quantity numerically. Measurement plays an important role in physics. Understanding how to measure quantities is essential for solving real-world problems like determining how long or wide a football pitch is. Now, let us look at some measuring tools and how they are utilized in measuring fundamental quantities like length. First, we have the meter rule. The meter rule is used to measure the length of an object. Some of you have seen a meter rule before, and if you haven't, do not worry. This is what a meter rule looks like. In measurement, we have what we call reading accuracy. This simply means the smallest graduation. In the case of the meter rule, the smallest graduation is 1 mm, which is also equal to 0.1 cm. The meter rule is calibrated in millimeters and centimeters. Pay attention to this. The smaller lines represent the calibration in millimeters while the longer lines represent the calibration in centimeters. For example, we are asked to determine the length of a pencil using a meter rule. All we have to do is place the pencil horizontally starting from point 0. Then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The counting continues until we get to the point where the pencil ended on the rule. Now, bearing in mind that 10 mm equals 1 cm, the length of the pencil is 7.3 centimeters. Take note of this. When reading a measurement from a meter rule, do not read from an angled direction. Instead, look vertically downward on the markings. This is to avoid parallax errors. You're doing amazingly well. Now, let us look at how we can measure mass using a beam balance. Mass is the quantity of matter contained in a body. Again, the mass of a body can be measured with a balance. Now, we have various types of balance. For example, the direct weighing balance, the spring balance, the chemical balance, and the beam balance, etc. To measure with a beam balance, for example, you need a beam balance, the object to be measured, and lastly the standard mass. Now, you should understand that a standard mass is a known mass value used as a reference point to calibrate or compare the mass of an unknown object. Let's proceed. Place the object in the left-hand pan. Then, place the standard mass in the right-hand pan. Make sure to swing the beam at about a point in the center. Then, add the standard mass, one after another, until the point balances on the central mark of the scale. For example, to determine the mass of an object, using a beam balance with a 100 gram standard mass. Solution: place the object on the left-hand pan. Then, place the standard mass in the right-hand pan. Adjust the beam to reach a balance, and then read the measurement. If the beam is twice the standard mass, then the mass of the object equals 2 times 100 grams, which gives us 200 grams. There are certain precautions to take while using the beam balance. First, make sure objects are dry before being placed on the scale. Secondly, use the forceps instead of your bare hands for picking up objects. Lastly, allow hot objects to cool before weighing. Remember, accuracy is our major aim. So anything that will alter the results should be avoided. Well done, students. So far, you are doing great. Now, we will look at how we can measure time using a stopwatch. The most natural time is the solar day, which is signified by the passing of day and night. It takes the Earth 1 day to complete 1 revolution about its axis. Currently, we use the clock to measure and indicate time. Again, in the laboratory, the stopwatch is used to measure the time it takes to complete some laboratory activities, such as melting and boiling. For example, to measure the time it takes for candle wax to melt. Firstly, set the stopwatch to 0. As soon as the candle has been lit, the timer presses the start button to begin timing. Moving forward, when the candle wax is all burnt, the timer presses the stop button to halt the timing. Therefore, the time displayed on the stopwatch is the duration it took the candle wax to melt. Well done, students, you are doing amazingly well. Let us see the dimensions of some physical quantities. Any quantity which can be measured in units of time has a dimension of time, t. Therefore, we define dimension as the physical nature of a quantity. For example, we have the dimension of length as capital L. The dimension of time is capital T. The dimension of mass is capital letter m. The dimension of temperature is theta. Also, the dimension of current is capital letter I. The dimension of amount of substance is capital letter N. The dimension of luminous intensity is capital letter J. Now, I want you to note that we define derived dimensions with respect to the derived quantities. For example, the unit of area equals meter squared, that is length times length. Therefore, the dimension of area equals the dimension of length times the dimension of length, which equals L squared. Another example is force. Force equals mass times acceleration. Therefore, the dimension of force equals the dimension of mass times the dimension of acceleration, which equals mL t to negative 2. Well done, students, you are doing amazingly well. Now, let's go over to the assignment I have for you. Ensure to pause your screen briefly and copy down this assignment. Assignments will help you master what you have been taught. We have come to the end of today's lesson. Before you go, let us summarize what we discussed. Remember, we discussed different measuring tools. We described how to take measurements appropriately. And finally, we derived the dimensions of some physical quantities. In our next class, we will talk about position. See you in the next class.